So let's see what our app currently does. All right, so we would add some stuff to the front, blah, 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 add some stuff to the end, remove front, so on and so forth. Okay. All right, so next thing we would probably do is we already have what we're adding. Now we need to add a another edit text for where we want to add it, right? And then a couple more buttons for add or remove at index. So I'm going to go ahead, I'm going to put that next edit text beneath here, and then actually put those two buttons beneath that to kind of indicate that they're like together. You can put them wherever you want on your interface. Okay, so I will go ahead and grab my plain text here, and I'm going to put it down here before the scroll view. And we're going to call this guy index ET. And I'll go ahead and center that. And we'll just have it say index. And we'll take the text out. And actually, that guy would have been, instead of plain text, would have been, so under input type, this is where you can change the keyboard. So I'm going to change it to number. That'll give me the numeric keyboard as if I had grabbed the number one from down here.
Will that change the data that we get out of it?
No, I think you always get it as a string. Okay. This just gives you the whatever keyboard pops up to, so it will control the type of data they can put in. All right, so then I'm going to give myself a couple of buttons. So I'm going to give myself a horizontal linear layout. Put that right underneath the edit text. Change the height to wrap content. And I'll throw a couple of buttons in there. Did I miss with the second one? There we go. All right, so we'll have added index. And we'll have remove add index. Okay, and we could probably have these be exact sizes so they're symmetrical if we wanted to change the width of them. I'm just going to leave it alone and move on with life. Okay, let's make sure that our interface still looks okay with all that stuff in there. Just add a couple of things, make sure they're still showing up. Looks like they are not. So my linear layout here is, I thought I changed the height to wrap content. Oh, I made it for this guy? Oh, I did, thank you. Oh, actually, it needed to be that too. But regardless, this should look better now. All right. So that's working. All right, so now we want to go ahead and let's go ahead and get these couple of buttons hooked up and get us reading in from the index just to make sure we're getting the right information in. Then we'll go write the logic to have it do a bunch of stuff. All right. So we'll go into main activity. I'm going to give myself access to that other edit text. So this is private edit text, what I call it, index ET. And this dot index ET is equal to the edit text version of this dot find view by ID r dot ID dot index ET. Oh, does it? So you're saying we don't actually have to do that?
I think this new update.
Okay. Well, yeah, I'm going to do it anyways. But that would be helpful if it does that. So, although this is higher performance, because if it's casting it during compiled, well, since it's a compiled language, it wouldn't necessarily be higher performance. It would just compile slightly slower because it has to do the extra lookup to find out what the type is. Yeah, I don't know. I guess pick your poison. But the idea here is, and actually that could be a little misleading too, because that probably doesn't work for everything. So the idea here is that find view by ID spits out a generic view. And in general, when we're working with any sort of objects in any language, doesn't have to be Java or whatever, if something comes out as something that's generic, and that's kind of from the inheritance model. So if we have something that returns an object, and we know that all objects, if we create a cat object, we know that that extends object at some level, right? So that's in that hierarchy. Well, if something comes out, if we have an array of objects, we can store anything that is an object in that array. But when it comes out of that array, we're gonna pull it out as a generic object, even if we know it's a cat or a dog. If we want to use it as a cat or a dog, we'll have to typecast it to cat or dog so we have access to the methods for that guy, even if that's what he actually is. Make sense? You know, we have to let Java know that this guy is actually one of these. Treat him as such. So if they've allowed. Here, I'm going to actually test this because I know. So you're saying that's cool. Now, are you saying that's cool just because it's not showing an error here?
Well, no, because
later on it works.
No, it tells you don't have to. This is a redundant cast. Like in the IDE, it will give you a hint. So select the one with the edit text.
This one?
Yeah. And read.
Oh, I see. I'm going to look at something here. This dot find view by ID. Well, no, I want to see if this guy, there's multiple versions of this guy now that will return different types. No, he returns a generic type. So this indicates a cast to whatever this guy is.
Because you already
so since I define this guy as being an edit text, this is auto casting whatever this is to that type. So if I, for some reason, made this guy just a view, let's say, this is still going to say this is okay. If I try to cast this to an edit text here, yeah, see, it's giving me the redundant thing because it's saying, look, we'll go ahead and cast it. Well, actually, that's weird. So let me change this to text view.
No.
So I'm trying to store an edit text into a text view. Yeah, it's not giving me the redundant thing anymore. So it's saying that's required. So if this guy, so this is saying whatever this is, it will go ahead and cast this to that. Yeah, interesting. Now the question though is that a Android Studio thing? Because I don't think that's a Java thing. You know how Android Studio has been doing things like this, where it like puts in the name. That's not a Java thing either. I wonder if this is something specific to Android Studio, where it's saying, "Oh, you don't actually have to cast this. We're doing it for you."
Does Gradle have to do anything?
Well, Gradle would be part of Android Studio, how it handles things. So it's possible that it's going through and it's saying, "Oh, well, whatever this type is, I'm going to go ahead and throw the cast in there for you." Yeah, I guess do what you want, but I'm going to encourage you to keep casting it. If for nothing else, you don't run into inconsistency issues later on with other types of programming where something comes out as a generic. Like if you have something that's a generic object, he's not going to be able to call cat and dog methods. You need to turn him into a cat or dog in order to have him do cat or dog methods, even if you stored him in a variable. Um, Let me actually think about that. If I store him in a variable of type cat or a variable of type dog, will he get those things? He might. That could be a Java thing. Well, we'll just go with the catch-all. This is never wrong. We'll go with that. Just like with the opening and closing curly braces for for loops and if statements, those kind of things. Um, it's possible this could be redundant if you have the variable on the left-hand side, but it seemed to be doing more than that because it was checking when they weren't the same. So I would say good programming practice would be to still do that. At the worst case, it makes your code compile a little faster because you're explicitly saying this is the kind of thing it is. You don't need to go look it up. Pick your poison, I guess. All right, so we have our edit text. Let's go ahead and write our button for the add and remove an index. So public void add at index button clicked. And then public void add or remove add index button clicked. All right, so we have our couple of functions here. And then all I'm going to do is I'm just going to print out whatever's currently in that text box just to make sure that everything's reading through and all that stuff. So I'll do a system.out.println this dot index et dot get text dot toString, although it would have printed it out without the toString. And I'll do the same thing here. Okay, so let's go hook those up now. So we'll go to our two buttons. Here's our add at index. Go to the on click. And this is the add at index button clicked. Then go to remove at index. Remove at index button clicked. All right, let's go ahead and test those two. We'll type something into the index box. I need to make sure I have my Logcat open here. Click. All right, I have a feeling that one of these other interfaces is covering up that guy. All right. There's that guy. Those two guys are fine. Scroll views down there. That's fine. No. Nothing was covering them up.
Can you just not select it somehow?
Well, it's possible. Let's click down there. Actually, I have problems clicking my button down there too. No. That's terrible. All right, let's see who's blocking who. Okay, so that guy's not part of that. Looks clean. Here, let me just let me dump that. I'll throw it back in. Wonder where those are all going. I'm dropping them in there. I'm just going to steal the text from in here. We'll go down here right before this linear layout. We'll paste it in. We'll change the thing to index ET. Now it should look right. Change that to say index. Just out of curiosity, let's add it near the top there. See if those linear layouts are messing with it. Yeah, I can click on it now. This scroll thing down there really sucks. All right. So that's putting it under the linear layout. Why is that trying to put it? So that's in the right place. Well, actually, let's just see if that guy will, let's see if it'll let me click with it down there. Maybe it doesn't like me having it living between two linear layouts. I need to throw it inside of its own linear layout. Yeah, see, I can click on it down there. All right, well, if you really want that, we'll take another, pick your poison, horizontal or linear, whatever. I can't click on them. All right, so here's the empty one. I'll drag this guy up there, so that's inside of that linear layout. And then I want to move this linear layout down. And see, it doesn't want me to drag it underneath that. Let's go to the text. Steal it from there. We'll just scroll down right before the scroll view. I'll throw it in there. And I want this guy to wrap content. All right, well, it looks correct there. It looks just like it looked a few minutes ago. Yeah, I can click it now. So it didn't like, I'm not even sure I can give you an answer why. It didn't like me having a normal widget sandwiched between, I'm guessing, any of these linear layouts. But I happen to be trying to put it between this linear layout and this scroll view. So I instead had to put it in its own little horizontal linear layout to get it to fit, or get it to be clickable. Or you could have just put it at the top and it would have worked. So I guess whatever. All right, so we'll put a number in here. Let me click on my Logcat here. Just to make sure everything's hooked up, we'll click Added Index. Now I can't click the buttons. So good. It's actually really funny, sort of. Nothing's being blocked. I am going to kill my emulator and restart it. Something funky is going on. Anybody else have this issue, or did everybody just put their text box at the top?
I use the same one.
You did the same thing as I'm doing here?
No, I use the same one.
Oh, you use the same text box. Well, then how'd you get your value?
Um,
Because you're doing a value as well as a position.
no, actually, the also instead of using the index, we use that as an index to remove.
I put a couple space.
Yeah, see, I was able to click at that time. Index ET. Make sure these buttons are hooked up. So just add that index. Make sure those buttons are hooked up. They're not. I'm gonna dump that, close it. Switch these buttons back to none. Go back in here. Add an index. Remove an index. There's added index. There's remove an index. Why? None of my buttons are working. It's a disaster. That's new number ET. Let's kill that emulator again. All right, that button works. Index 22. I'm hitting that button. Nothing is spitting out. I'm just gonna set the text of that thing instead of trying to print out to the console. Maybe it's not. Oh, this is it. Didn't somebody teach me that lesson last time? Who told me last time? When the thing is disconnected. I think it's been working, well, ever since the buttons have been working. Yeah, add it, remove. Those are working now. But I had this thing set at this disconnected one, so nothing was showing up. So I think if I actually have this do that now and rerun it. .22 in here, added index, there's my 22, remove it index, there's my 22. Okay, well we finally have our interface functional. Hopefully this was a good example of why I actually spend that time to test to make sure that edit text and the buttons and stuff all work before you actually go start doing logic. Okay. Now let's do the logic. So the idea here is that when we say remove at index, let's go back to our picture of our list. We're going to remove from a zero-based index. And we should probably go ahead and handle the couple of special cases first. So if we say remove from bucket 0, we might as well say remove front. And then if we say remove from the end, how do we ask? Well, let's start with the simple case. Remove from the front, we've already written that, right? So if they say remove at index, if, let's just go ahead and get a int index is equal to this dot index get text dot toString, and we want the parse int version of that. All right, so that'll give us the actual number for our index, right? So then we ask the question if index is, we might say if it's greater than or equal to 0 initially, because maybe we don't want to do anything if they say remove from index -3. Maybe we just decide that's not a thing we respond to, right? So we're only going to do stuff if they give us a legal index. Now, we're going to probably tack something onto here in a minute, because we need to know how many things are in our linked list to know whether they've asked for something at the end. So let's just put the special case in here for the front. So let me minimize this. Are we removing the front? So if index is equivalent to 0, then we might as well just say ll dot remove front. We'll go ahead and tell our linked list to remove front. Now remember, this guy had a exception dealy thing that happened. So what we'll go ahead and do is just throw this inside of a try catch. And then do nothing because we're lazy. So if they were trying to remove from the front, go ahead and try to remove from the front. If you remember from our linked list, remove from the front does the removey stuff, and then it also updates our container, so it will make our thing actually change because we've linked those two together. Okay, now we want to ask, are we removing from the end? So how do we ask that question? I'm going to say else if index is equal to something. Now, if we have, since we're working off a 0 index thing here, right? We're kind of treating our linked list just like they're arrays. So if a 5 bucket array would have legal buckets of 0 to 4, right? So if we said remove bucket 4, that's removing end, removing the last legal bucket, correct? How do we ask our linked list its length? Wouldn't that be handy to be able to ask the length of our linked list, similar to asking a string its length or asking an array its length? Now, if we go into our linked list right now, I know some of you have done this on your homework previous to this, where you had a integer up here, maybe called count. And let's say when we first create a linked list, this dot count is equal to 0. Nothing in it, right? Now, whenever we remove something, we'd say this dot count minus minus, but only if we actually remove something. Notice here in the else, we don't remove stuff, right? So if we remove stuff, count minus minus. If we remove stuff, count minus minus. If we add something, we want to say count plus plus. So make sure you don't put the count plus plus in here because you're relying on add front to do the count plus plus for you. Otherwise, you'll have a double count. So otherwise, if we're going to add to the end, we go ahead and do the add to the end stuff. Say count plus plus. There's our display, whatever. All right, so now whenever we're adding, we're doing count plus plus. Whenever we're subtracting, removing, we're doing count minus minus. Go ahead.
Do we want to set the count to -1 at first?
Why?
So that the count of the, so when we have our element at bucket 0, then the count will be 0. We can just check if the two are equal as opposed to risking it off by 1.
Well, why would we risk it off by 1 if initially, we literally have 0 elements in our list.
Right.
So its length would be 0, right?
Right.
And then when we add something to the list, its length would then be 1. Oh, you're saying for the remove it index.
Yeah.
See, we're not going to have to deal with that because we're treating it as a special case. We're saying if you want to remove from 0, we're going to call remove front. We're going to offshoot it to that.
If we remove from the end of the list, we would have to check if index is, or index plus 1 equals count.
Or we would just treat it the same way as we treat strings. If index is equal to the length minus 1, right? That's the last legal bucket in our linked list. Then we're consistent. We treat arrays that way. We treat strings that way. We treat our linked list that way. So the last legal bucket in a linked list is its length minus 1. Does that make sense?
Yeah.
I get what you're saying. You can make the math work either way. If you want to set it to -1, then you just make sure the math works from that point forward. But then if you set it at -1, the first time you add something, now its length is 0. Well, its length really is 1, right? So I think this is more consistent with how it seems like it would work. So let's say public int length, and this will return this dot count. So we've now taught linked lists how to return their length. Their length is how many elements are in the linked list, just like how many elements are in an array, how many elements are in a string. It's going to give us that same meaning. So it's a 0-based construct. So now we'll ask if index is equal to ll.length minus 1. If the thing you're trying to remove is the last legal thing in the linked list, then we'll go ahead and we will try remove front, remove end. Catch, exception E, and do nothing. Okay, So these are our two special cases. This whole thing here says only even try to do anything if you give me like a legitimate number. Now, we do need to expand this though. A legitimate number is going to be greater than or equal to 0 and index is less than LL dot length. Those are the legal values you can try to remove from the list, right? 0 to its length minus 1. Anything outside of that, we just won't do anything. Or if we want to do our little toasty thing, else toast dot makes text. Context is that. Duration is the duration yet? No, text is next. Invalid index. Duration is toast dot length. Do we decide which we like? Length short? I'll just do length short. Dot show. So that'll spit some text on the screen. That'll, if we give it a bad number. All right, so let's go ahead and test this for those two special cases. Try to add from the, remove from the front, remove at index 0, and then remove from the end, remove at index whatever, and then we'll try to give it a funky value. And then we'll go back and write add at index. All right, let's get a couple of things added here. All right, so I have a 1, 2, 3. Let's go ahead and remove at index 0, so it should get rid of the 1. Then we'll, oh, we probably empty that guy out like we've done before. So now we have a 2-bucket array, so let's go ahead and remove from index 1. That should get rid of the 3. All right. Now let's try to remove at index 100. It should be bad news bears. So we should get our toast. Invalid index. Have we seen that movie, Bad News Bears, or is it just a weird, funny thing that I say? How many of you have never seen Bad News Bears? Oh, it's classic. How many of you never heard of Bill Murray? He's not in that movie. It's just one of those things that popped in my head. No. Have we heard of Bill Murray? Oh, we get the of course. I guarantee in 10 years, my students will not have heard of Bill Murray. Go ahead.
Is there like a reason why it's called toast?
No, actually, that's a good question. I want to say, I'm guessing it has to do with kind of like, you know, doing a little toast like that, like you had a wedding or something like that, where it's just up for a second and comes back. But I don't know. I'm not sure. It does kind of feel compatible though with Google. Like Google, like name all their operating systems after like desserts and stuff like that. So it's entirely possible it literally just means toast. Just bread that's been toasted. That would be kind of compatible with it. I mean, all Google's operating systems are Lollipop and Oreo and ice cream cone, or is it ice cream sandwich? Ice cream sandwich. Yeah, so I mean, they just pick food items, so it's possible it just literally means toast. Would be the Google way. But now that you've asked it, that is going to be a question on an exam. And
It's probably like an easy question.
It probably is. Here, let's get the answer. The toast song? I actually think maybe sort of.
The make toast song. I think we should watch it.
Called toast.
I just found it. It's because it pops up.
Pop up like toast from a toaster.
Oh, that makes sense.
This is a guess. It's not really. Well, that's from Wikipedia.
Yeah, it sounds legit.
Let's see.
I think we should just that's biblical at that point. So at some point you kind of feel like they're gonna, somebody's gonna like put Wikipedia together in such a way where you can like reference like verses. Yeah. We have to listen to. It's called the Make Toast. Is it on like YouTube?
Yeah.
And it's classroom appropriate.
Oh, we can get it.
What does it mean anything? All right, so Make Toast song.
The one that says yeah, toast. Yeah.
This one.
All around the country and coast to coast. People always say, what do you like most? I don't want to brag, I don't want to boast. I always tell them I like toast.
You seem like way too happy about this.
Yeah, toast! Yeah, toast!
I have seen this before.
I get up in the morning about 6 a.m. Have a little jelly, have a little jam. Take a piece of bread, put it in the slot. Push down the lever and the wires get hot. I get toast. Yeah, toast!
Like you know all the words.
Yeah, toast!
And we don't sing it like that at all. But
Continue.
what do you mean?
Well, you got to pick up where we left off here.
The funny thing about
Does it get any better, or is that pretty much the same?
No, it gets better.
Oh, it gets better.
Well, I think it's funny.
Well, the whole thing. Like, do we need to keep going, or have we got the taste of toast?
Well, then we talk about the different kinds of toast.
Oh,
You can have light toast or you can have
oh, the French toast. And...
Now, there's no secret to toasting perfection. There's a dial on the side, and you make your selection. Push to the dark or the light, and then, if it pops too soon, press down again. Make toast. Yeah, toast! When the first caveman drove in from the dregs, didn't know what would go with the bacon and the eggs. Must have been a genius, got it in his head. Plug the toaster in the wall, buy a bag of bread, make toast. Yeah, toast! Oh, we must
I can imagine they were smoking something.
Oh, croissant de vous avez? Maurice Chevalier, I will tell you. Oh, we marry baguette bonsoir. French toast! French toast! In Chicago, we're on the Bob and Tom Show. Yeah, toast! Toast.
We made it through it.
How about imperial toast?
Imperial toast.
Funny thing is, I've actually heard someone sing that at a wedding when proposing a toast.
Okay. Oh, this is Star Wars thing.
Yes.
So what are they like scraping the toast?
It's just a toaster that makes weird toast.
Oh, I gotcha.
And they managed to make them imperial.
Now this might be a first time though. I believe that whole getting off topic thing, 100% of it was you. You asked the question, where does toast come from? So
I can take the
that's fine. At least we know now, and then we also know the song. So what we'll have to do is on an exam, to answer, it'll be some like impossible question, or stand up, middle exam, sing the Make Toast song.
I would do it.
What were we doing? Oh, yeah. Have we actually tested our toast yet? I think we did, didn't we? We said 100, remove an index. Yeah, invalid index. Okay. So we're handling our two extreme cases, right? Add from the three extreme cases. Add from the front, or remove from the front, remove from the end, and then remove from impossible place. So we got those three. So now we can assume that if we're in the else right here, we are removing from the middle somewhere. All right, so we want to remove from the middle somewhere. Now we need to go and draw our picture. So let's say we want to remove from index 1, for example. All right, so our index we've put somewhere here. We'll say index is equal to 1. We're going to go ahead and we need to get something pointing at the dude we're going to remove, right? So we're going to need a node to remove. And this guy will start off at the beginning of our list. And then we could probably actually, since we know exactly how far in we're going to go and we know it's illegal position, we can actually just write a quick for loop that goes through one time and just jumps this guy to the next. So let's go and write that real quick. So we'll go ahead and create a node to remove, and this guy will start off as this dot head. Hold on, we're not, we need to be inside the linked list. So go into linked list. Why did I write all that logic out here? Well, I guess we kind of need to do it out there anyways because we are going to do our toast out there. So that's fine. So linked list, we're going to write a public int remove at index. Now, this guy doesn't actually need to throw an exception, does he? Because we know the index you're trying to remove from when we call this guy is legit. Now, we could say that you might want to have him throw an exception just in case if you're writing your linked list to be very generic. We know in our particular application, since we're error checking on the front end, that we will never pass this guy an index that's going to be bad. We'll always pass him an index that's a legitimate index that he should be able to remove. All right, so you can decide whether or not you want to make your linked list more general purpose where you can take it to other things. Probably would make the most sense. So we'll have this guy throw an exception. We'll ask the question right off the bat, if index is, well, if this dot head, if this dot head is equal to null, and maybe this is what he was getting at before he had to leave for his next class. In this particular case, we can't check to see if index is less than 0, because we might try to remove from index from a list that has nothing in it. So a list that has 0 elements in it wouldn't have an index 0, but we couldn't ask is index less than that because 0 would be equal to 0 and it wouldn't fail it. So we'll ask if head is equal to null, or, so that means we have nothing in there, or index is less than 0, or index is greater than or equal to, we can say this dot length, or we just say this dot count. If any of those things are true, we have an illegal index that was passed to us. So we will throw a new exception illegal index. And we mean it. No, I can't decide if are you still giggling from the toast or is this new joke? All right, else. else. If we're here, we know we're removing a legitimate thing. Realistically, we should probably all right, I'm going to show you how we might deal with I'm going to move some of that logic in here. So if we are in this else, we know we're dealing with legal stuff. So I'm going to rewrite some of the stuff we had out before, then we'll actually deal with a real exception. We'll truly deal with it. So I'm going to say if index is equal to 0, we'll go ahead and say this dot remove front. Else if index is equal to this dot count minus 1, we'll go ahead and say this dot remove end. Else, we'll do our other logic. Remove from the middle. All right, so we've basically pulled a lot of that logic we had out in our main activity into remove at index. So what I'm going to do here is we're going to go out to main activity. Now this does presume that index is an actual number. So we are making that assumption that index is a real number. So I'm going to get rid of, well, I'll write it again up here. So we're going to say we're going to try to do something. What are we going to try to do? We're going to try to say LL, or this dot LL dot remove add index, one index, index, index that we just read in. And then we will potentially catch the exception. And if something bad happened, that's when we make toast. All right, so that's going to be right here. All right, so that's the same logic because we've put most of that logic inside of remove at index. And then inside of remove at index, if something bad occurs, we throw that exception. And what happens out here is we try to do this. It either works smoothly or we catch the exception. What do we do if we catch the exception? We print out invalid index, or if we really want to, we would say text is e dot get localized message is the actual message that came out of there, which is going to say illegal index with a whole bunch of exclamation points after it. That way we could have multiple types of exceptions and this guy spits out whatever that particular exception was. Does that make sense? This does the exact same thing we had it do before. It just, we've encapsulated more of those details inside of the linked list and then have our actual interface here, well, the logic directly behind our interface. Try to do something. If it fails, spits out then it makes toast, I guess. I have a feeling this toast thing's going to become a problem. I don't know. I kind of like jokes like that, actually. Things you can like just interject, but it's coming up too much right now. It's gonna get old quick, so we got to toast less. So we can't check for errors as much. All right. Now, for this remove at index thing, remember, if we remove front, we want to go ahead and return whatever that guy spits out, because remove front's going to spit out an int. If we remove end, we're going to return whatever remove end does, because this guy we've advertised is going to spit out an int. Otherwise, we need to write our logic in here, so we're going to say node to remove, and this guy will start off as this dot head. Now we know we're going to be somewhere in the middle here, right? So we'll just create a little for loop for int I is equal to 0, I is less than index I plus plus. So we know how many times we need to jump through our loop. We need to what's the What's the word? Go through the linked list. No? T. Does it start with a T? Traverse. That's it. Traverse. Old. I'm getting old. So we need to traverse the linked list. So we're going to say node to remove is equal to node to remove dot get next node. And we'll do that this many times. So when we're done with that, he should point at the node we're going to ultimately remove. All right. So now we need to decide how we are going to actually perform the surgery. So we say this is the node we're going to remove. If I want to get him to go away, I need this guy to hook up to this guy, right? So that means I'm going to need to know about the node that came before him. All right, so how do I figure out what node came before him? Well, I could do it inside the same loop. I could have it kind of have this like lazy thing drag behind him. Or if we did that, we can do something along these lines. So I can say node prev node, maybe start that guy off at null. And then before we change node to remove, we'll say prev node is equal to node to remove. Preserve the guy before him. Does that make sense? So we have this little dude here. This is prev node. So initially, this guy's pointing ahead. Okay. So think of prev node like in some of those spy movies where he's actually tailing this guy, but he doesn't want him to know. So he's kind of just like looking out nowhere. So all of a sudden, this dude takes off, and this dude's a little bit behind him, so he goes right where he used to be. That makes sense? Then this guy's where he wants to be. So now we have prev node pointing at the previous guy. We have node to remove pointing at the next dude. The other thing we could do is we can say, have a second for loop that goes through index -1 times.
Oh, wow.
Well, I mean, you could just do the exact same for loop as this, but say index -1. You just have two loops next to each other. One of them races node to remove up to where he needs to be. The other one races prev node up to right before that. Does that make sense? So you can do it in two loops, or you can do it in one loop, whichever one makes the most sense to you. Okay? So we'll just do it in one loop there, using our little our pattern of one guy tailing another guy. Okay. So when we get to that point, we're looking at something that's like this. So what do we need to do? Well, we need to have prev node set his next node to node to removes next node. Prev node dot set next node to node to remove dot get next node. Make sense? All right, so that does this little move. Then we want to say node to remove dot set next node to null. Node to remove dot set next node to null. That disconnects it. And then finally, remove or return node to remove dot get payload. Have we done everything we need to do to remove that guy? Return node to remove dot get payload. All right, so that should be remove at index. Oh, thank you. Very important. We don't update the count here, right? Because remove front updates the count. We don't update the account here because remove end updates the account. We will update the count here because we did the rearranging there. Good catch. I obviously did it on purpose, but you were right on top of things. Great toast. Ay, ay, ay. Okay. Let's test that real quick. This guy should work just fine. Better work better in our interface. That really is the crappiest part of programming, is making an interface. Just writing code is like so much better. Well, because how many applications do you use in your computer that just have just a text thing? They all have buttons and things you click, right? But the good news is, for computer science folk, this is about what we do. We would just make kind of functional interfaces that we'd, while we're working on this, some designer somewhere is actually creating the pretty interface, and they give us the stuff afterwards, and then we just basically skin our interface. We make all the buttons look like the buttons they designed. They still do the same thing they used to do. We just make it look the way it's supposed to look rather than our pile of crap. But yeah, still a thing, I guess. Let's see. Another interesting thing. I mean, I use Android for a couple different reasons. One is because I don't have to worry about what kind of computers you have, but also this pattern of how Android solves interfaces is actually pretty ubiquitous across industry, except for how Apple does it. Now, what's funny is Apple's interface builder is significantly better than this by like leaps and bounds. This interface would have been like no issue whatsoever. We wouldn't have been embedding things. We just drag it on the screen and it's done. It looks beautiful.
When are we gonna get to it?
Probably in like either a special topics class or if you want to do an independent study with me or at a hackathon, something like that. I would prefer to teach iOS development in class, but then many of you would have to come into the lab to do your homework. So even though that's completely reasonable, most students don't like doing that. And then I have to start, worrying about whether our lab is working down there, which is a whole nother problem. But yeah, I mean, if you find some of this frustrating, iOS programming makes so many of these interface issues go away. You still have the programming stuff, and then you learn Swift, and it's all the same crap. But if you're interested, we can do an independent study or something on it, or a lot of times we'll do one of our hackathons. We'll have a mobile app, and then you can just let me know beforehand, and I'll put you on some team that is going to do something for iPhone rather than something else. You can learn about it. A lot of these things cross over. I mean, it's not like learning a whole new ecosystem. You just will pretty quickly realize that the interface builder for iPhone is better. It is just the better tool. Okay, so let's get a couple of things in our list here. So we'll add front. We'll add end. We'll add end. And then let's remove at index 1. So she get rid of the 2. We never actually updated our interface, but I'm pretty sure it did actually work. So in order to update our interface here, one last thing, we'll steal the code from this guy. So right before we return, we will remove add index index. Row. That should actually make it get removed from our container. So there's our 1.3. So that removed from the correct place. All right, so we'll have to do this next time, I guess. We're going to do add index. That won't take us very long. So in the meantime, I'm going to give you the next reading assignment here. All right, so we have, what have we read up to? So we've we have been in chapter 2, right? What have I had you read so far in here? The singly linked list stuff? So I had you read through all of chapter 1? Seems like I would have. Did I have you do chapter 1? Or have I not given you any reading yet?
You told us to
Read what?
the link list.
Link list stuff, yeah. So you should have read. If you haven't, just go ahead and read it and do the interactive stuff. So chapter 2, make sure you've done all the singly linked list stuff. Go ahead and read the doubly linked list stuff. We're not actually going to do it in class. You'll see that it's just makes some certain things easier from what we've done, but then it takes a lot more, you're keeping track of next node as well as previous node for each node. And then go ahead and read. So read everything through 2.11. All right, so we're going to start working with stacks next class. All right, and I'll put the Bible homework up here in a few minutes. Remember today, faculty, student, staff, Bible study. Huh? Cancel what? What about my free lunch? So that means today's the day you hear my life story?